Great, thank you, Steve. And also thank you to the MSSP committee for putting these on. It's great to have an opportunity to talk about product and tech and exciting things. So always good to be here. Now I'm going to talk about event detection, and that's high frequency data collection with wireless devices. So pretty exciting stuff, if you ask me. But how I'm going to do that is first kind of look at automated monitoring systems, like where is our starting point that we have applications for wireless devices and for wireless devices that are reading at high frequency. From there, we're going to look specifically at wireless tilt meters. That's where the event detection comes in with the Worldsensing wireless tilt meter. And then high frequency data collection with that tilt meter. How do those two things mix? Because wireless and high frequency aren't terms that you normally put together in the I&M world. And then we're going to go into operational mode. How does this actually function? And what can you do next with it? What is the next step in the advancement that you can use this system to get to on projects? So like I said, we want to start with a baseline here, just talking about the same thing, and that's with automated monitoring systems, right? The kind of the principle that I always think about when we start with a monitoring solution is, what are the questions that we're answering with the system in place, with the instrument we're looking at, right? That's the kind of the golden rule. If there's no question, you probably don't need an instrument. So first you've got to start with understanding what questions you have, and then the instruments that you're going to use to answer those questions. From there, we need to develop the parameters. So the project team needs to look at those questions, look at the instruments they're going to be putting in place to answer those questions, and understand the parameters like the locations the instruments are going to be installed in. What kind of allowable movement or anticipated movement do you have in normal conditions? What kind of baseline monitoring do you need to maybe confirm that? From there, you're looking at your threshold alarm levels and your alert or alarm levels, the frequency of your data collection, how quickly do you need that data to be coming in, those data points, and then how often do you need to be looking at those, the data transmission. From all of those parameters, you also need to keep in mind, what are your actionable steps if you cross a threshold, if you get an alarm level? And then once you have all those things in mind, you're going to develop a scalable solution for the project that establishes all of those parameters for all of those instruments, and it gives you a chance to both grow and shrink what the project needs, right? You're going to have more instrumentation at some points and less at other points, so you want to make sure you have a program that can suit a full project from the day you need to start, from the day it wraps up. So when we talk about automated systems, I'm really speaking to wireless. It's not just that that's what I get paid to do, but I also really happen to like wireless automated systems. So with these systems, we're talking about a couple things, and you can see them really clearly in this flow chart. We're starting out with the sensors that we're connecting to, or the sensors that are giving us our data value, and we're connecting them to a data logger. In this case, these wireless data loggers are programmed to be sat out in the field, connected to these devices, and working for a long time. They're battery operated, and they're communicating with long-range radio. And that's allowing them to sit out there for 10 years, 15 years plus, running on the same batteries they started with, so low maintenance systems. They're configured with a smartphone, as long as you have an Android, and you're putting them in place and letting them do their thing. But that data has to go somewhere. Like I said, they're working with long-range radio, so the data is coming from that data logger, and it's transmitted with long-range radio to a gateway on site. And that way you can have sensors all around the site, all communicating to a central point where that data is then sent to where you're going to visualize it. And right in between that step, you'll also have a chance for additional management. You can go in and make sure the configuration is what you need. You can update it during the course of the project, reading frequency, engineering calculations that you have put in place, the way that it's transmitting, all of those things. And the transmission typically between that gateway where your data is sitting and that visualization where you're going to be ingesting and reporting and alarming, you're going to be able to determine that transmission, usually with cellular, but you can also do the local area network, you could do satellite, kind of, the world's your oyster. So, the humble tilt meter, that was a working title. I kind of meant to change it before I sent this slideshow in, but I clearly didn't. So, the tilt meter is an interesting one because this is a wireless device that is both the sensor, a biaxial MEMS accelerometer, or it's giving biaxial MEMS readings, and also the data logging component. So it's taking the readings, it's then sending them out. This is it, everything you need to get those biaxial rotational readings. It's a pretty durable device. It's meant to go in the field for a long period of time. At 6-hour reading intervals, the batteries can last up to 20 years. So that's pretty sweet. And then onboard storage for the device also allows you to keep 140,000 readings, including temperature, on the device for backup for manual collection if needed. But so when we think about 6-hour reading intervals, you're like, Emma, you told us this was about high-frequency data collection. If that's high frequency, you're joking. But this is actually a different way that we approach what we started out with as our standard tilt meter, and that's putting a different solution in the firmware on the device itself. So the high-frequency data collection comes with the event detection solution idea, where we're putting edge computing in the device. We're reading at high frequency intervals, and then we're transmitting at regular intervals as long as it's within certain parameters, alert levels set on the device. And when it exceeds those, we're jumping in and we're sending that data a lot quicker. So we've already seen what kind of that flow looks like with standard systems, and here's the flow with the wireless tilt meter itself. So we have the tilt that you're configuring with an Android device you're putting onto site, and there are a lot of applications that this might be used for. This particular one came about thinking about landslides, but there's a lot more applications, and I'm sure you can probably think of some as we go through the details where this would be relevant. But so the tilt meter is put on site, it's doing what you need it to do, it's transmitting through a gateway still, and then for the quickest results in getting that data where we need it to be, we're pushing it with MQTT protocol to your third-party visualization, and that's kind of the flow that we have going on. But let's look a little bit more at that operational mode and what that component means. So as you can see, here's an idea of what that tilt meter would look like if it was pulling in data. So we start out with normal state periodic readings, and that's the one that you see there. And so you can see that data line, that blue data line, is just chugging along, and it's, in this case, reporting anytime or taking that reading and giving it to us through the gateway, maybe every 30 minutes, maybe every 6 hours, maybe every 24 hours. But it's giving you a mean value, it's giving you standard deviation, so you know what you're looking at in terms of those rotational measurements. When that tilt meter exceeds the alarm levels that you put onto the device, the threshold that you used when you programmed it, it immediately enters the alert state. So first you get a message that the device is in alert state, so you know that something is happening, and then the high frequency collection also turns into high frequency transmission. So not only are we collecting at 3.9 hertz, so about 4 times a second, but now we're transmitting that instead of every 30 minutes or 6 hours, we're transmitting it every 30 seconds. So that data is going, it's collecting at 3.9, it's transmitting at every 30 seconds, and then you are able to see it, with a 2-second latency if you have 10 devices, or up to 5-second latency if you have 25 devices. So you're really getting that data in quite quickly. It continues through this alert state while those thresholds are still reached, while you're above or below that threshold. And then once the readings over a period of about 60 seconds return to normal, it actually ends that alert state and goes back into its normal state in continuous periodic sampling. So we can, see it a little bit more here. Going through that process, it allows you to have these tilt meters in place, to have the data that you need to understand just what kind of general things are happening on site. Then you know when there's actionable movement, when it's exceeding your thresholds at a quick rate, and going back, if that's the case, with whatever's happening on site to normal state afterwards. So what do those specifications look like? Is it still going to be giving good data, good readings? And we've tested this with what we call the Tilt 90X. So that's just regular standard tilt meter with external antenna. We've also tested it with the Tilt 90i. And that tilt meter is a little bit different. It was just designed with railway applications in mind, where you have vibrations from the railway use that might be impacting it, so a slightly different accelerometer in the guts, and then no antenna on the outside, because there's nothing a train likes to do more than give you a chance to rip off external antennas. So when I talk about long-range radio transmission for something like this, what does that mean? What is long-range or LoRa radio actually giving us? With these devices, we have North American example here and European example. Worldsensing is a company based in Barcelona, so they often test right there in Europe ahead of giving it to us in North America. But we're looking at 7.5 kilometers. I'm sorry they didn't give me this in miles. And flat areas with open sight, and still up to 2 kilometers when you have areas of different elevation. And one thing to keep in mind, this is what you're getting out of the event detection tilt meter when it's on site and it's reading and it's working. That same system can also be working with additional data loggers. It can be working with something that's reading a vibrating wire piezometer over there, or maybe an IPI on the other side. And those are also getting their data transmitted in and have slightly longer range because they're not working in the same operational mode that this is. So those can go up to about 10 miles or 15 kilometers. Now, we still talk about wireless devices needing long battery life, and I told you earlier that a regular tilt meter can get 20 years. I haven't had a 20-year project myself, maybe 4, so I haven't had the chance to test that out. But we have also looked at what does the battery do when it's operating at such a high reading frequency and with the data transmission, both in that normal state and in the alert state. And looking at 2 different battery types that we use frequently with our devices in a couple different temperature profiles. So, of course, Barcelona by our office, Singapore by another office, and I don't actually know where that third location is, so we'll skip over that. But when we're looking at a reporting period in normal state of 30 minutes or 6 hours, we're still looking about 2 to 2.5 years of that sensor working with its batteries just chugging along before you need to go give it a swap. So really an amazing time of life for a wireless sensor and wireless data logger to be out and in the field and working on one set of batteries. So how can we build off that, right? So we have the one step of the event detection, the wireless tilt meter. Maybe it's good for a slope stability project. Maybe it's a good application for jet grouting under a sensitive building. But in some applications, you might need to take it a little further. What else does your monitoring plan have down the line? What are the other requirements? So when we had in mind originally the slope stability issue, we came up with a way to incorporate the event detection tilt meter into what we call an early warning system. So this is giving us the ability to have the tilt meter doing its thing, having it set up in an event detection system, pushing that data through MQTT to your platform, and then from there, once the data hits the platform, it can actually trigger an action. So in this case, the one that you see here, we're using event detection tilt meters to then, through the software visualization platform side of things, then go to another device on site. And that device on site can put on a strobe or a siren. It can have a camera take a picture. It can have additional readings from other sensors. So it can be a way to incorporate an action plan that you might have when that threshold is exceeded in automatically without having to go through the project team to make it happen. So in areas where there's highly anticipated risk to the project team or the community at large, it gives a really good advantage to get that quick response to a threshold breach. So a pretty cool aspect to it. So we can see here, we're monitoring with the event detection. We're getting informed about those exceedances, and then the system is acting itself to give us confirmation, to give us warning on site, kind of anything that we need it to do there within reason. So a very cool way to take one piece of tech and take it to the next level to give us a little additional help on site and making sure we have a system that does exactly what we need it to. So, are there any questions? You in the back. No, I'm kidding. You didn't raise your hand.